Good morning. Today what we're going to do is finish off Unit 1 of Pre-Calc 30 talking about absolute value. You have some experience with absolute value. Maybe Pre-Calc 20 is when we first looked at absolute value. I would have started with an informal definition before we got into a more formal definition of what absolute value was. The general idea of what absolute value is in terms of an informal definition, the absolute value of b is the measurement of the distance that value is from zero on a number line. So for example, if I asked you what the absolute value of -5 was, we would be looking at a number line where -5 is, and I'd be concerned about what the distance is. And that distance would be 5 spaces. So that's kind of the informal idea behind absolute value. A more formal definition came when we were wanting to talk about writing the absolute value without the absolute value signs. And that led to us talking about a piecewise function, meaning that when we would take some expression that was in absolute value signs and we wanted to write it without, if the expression on the inside was greater than or equal to 0, if it was already positive, as distance is a positive measurement, then we wouldn't need to make any changes to that sign. Whereas if the expression on the inside was less than 0, like my -5 was, then we would need to change the sign. So an extra negative with a negative would turn an expression positive, like absolute value signs make an expression positive. We would work with expressions that were a little bit more involved. We needed to indicate where that expression was going to be greater than or equal to 0. And so this statement here is indicating from 3, including 3, and greater is where the expression is positive, and we wouldn't need to change it. So the x minus 3 that you see here stays exactly as x minus 3. But for those values where it make the expression negative, like from positive 3 and lower, not including the 3 this time, that would give us an expression that was negative, and so we would need that extra negative to change the negative value to a positive. So we spent some time in Pre-Calc 20 rewriting absolute value expressions without absolute value, so equivalent expressions, but without the absolute value signs. We also spent some time in Pre-Calc 20 talking about how to graph an absolute value expression when we know that anything that originally is negative is not going to stay negative, it's going to become positive. And so we started to see those V-shaped graphs that were very common with absolute value. Our goal today is to focus on the rewriting expressions without the absolute value signs. One of the reasons why it's important, and I kind of always allude to the absolute value signs kind of like jail. You can't do anything with these expressions. Nothing can come in, nothing can go out. So our goal today is to rewrite it as a piecewise function where we are going to indicate where the expression is positive and we wouldn't need to change it, where the expression is negative, and therefore we would need to change the signs. So the fact that we're talking about positives and negatives again leads us to the idea of sign analysis. So what we're going to do with this is we're going to factor our expression, which when you take a look at it, it has a common factor of x and a difference of 2 squares. Once I have those factors, then I'm going to go and take a look at sign analysis, because again, that's going to tell us where our factors are positive, where they're negative, and where they're zeros. And so again, our sign analysis, I start with indicating where each of our factors is equal to 0. So I'm going to start with the x. The x is 0 at 0. It is negative for smaller values than 0. It would be positive for values that are greater than 0. Our second factor of x plus 3 is 0 at -3, and it would be negative for smaller values than -3. It would be positive for any of these values that are larger than -3. Our other factor, x minus 3, kind of went out of order, no big deal, is 0 at +3. And again, it is negative for values that are smaller than +3, but it is positive for values that are larger than -3. Negative less than 3, positive greater than 3. So to finish our sign analysis, we would then take a look at multiplying the signs, just like the factors are all being multiplied together. So the 1, 2, 3 negatives is going to be negative overall. Right at -3, 0 times those other signs is going to give us an overall value of 0. In between here, 2 negatives and a positive make it positive overall. At 0, 0 times those signs is going to give me 0. In between 2 positives and a negative is negative. At 3, 0. And then after 3, all those positives are going to give me positive. So when we want to rewrite our expression, we are going to be rewriting it with no changes to the expression for where our sign is positive or equal to 0. So where I'm checking all of these off are what we want to see where the sign is not going to change. It's going to be able to be rewritten without the absolute value signs, and it would still be equivalent. So I'm just going to indicate what values we are talking about here. On the low end, we included -3 up to 0, including that 0, and then again at +3 and going forward to positive infinity. That didn't work out so pretty. Let me fix that real fast there. To positive infinity, and we always close infinities with rounded brackets. Now, when we want to talk about the expression that is negative, and we need that extra negative to change a negative expression to a positive, now we're looking at just where the negatives are. So we are talking about values that are from negative infinity up to -3, but not including -3. And again, between 0 and 3, but not including those values. They were already included up there. And so what we've done in this particular question is taken an expression, rewritten it without the absolute value signs, and indicated where we would be able to use this expression so that it would be equivalent. And for what values of x, we could use this expression that would be equivalent to the original absolute value statement. So that's our goal with these questions. And so you can see the factoring, the sign analysis that we're going to be using. We're going to try that again with this one. This particular statement has part of it with an absolute value sign and some without. So when it comes to rewriting it without the absolute value signs, there's a little bit more to this one because some is inside the absolute value sign and some is not. And so I'm going to need to, first of all, factor, because factoring is very important in order to talk about those positives and negatives using the sign analysis. So just to factor things, the quadratic that we see on the top is factorable. Two numbers that multiply to -12 that add up to -1, x minus 4 and an x plus 3. The denominator being that it is a difference of two squares, x minus 4 and x plus 4. Now, what is tempting with situations like this, I see a factor in the top and the bottom that are the same. I'd like to cancel them, but because of the absolute value signs, I cannot. That jail aspect, I cannot do anything with this expression on the top until the absolute value signs are gone. All right, So what you're going to see when I do the sign analysis is something a little bit different with this particular case. And it is true when you have expressions that are not entirely in the absolute value sign. So what you're going to see me do is this. I'm still going to start the same way. I'm going to talk about all my factors. There's the x minus 4 and the x plus 4 that are in the denominator. I sometimes like to put them in the bottom of my list of factors just so that I can keep track of which ones are going to be undefined because they're in the denominator. Then I have the x minus 4 and the x plus 3 that are in the numerator. All right. Now, let's just find where all of these factors are going to be a 0. We'll mark off those places and then we'll go from there. The x minus 4 factor, you see it in two different places, but it's a positive 4 that's going to make them 0. The x plus 4 factor is going to be 0 at negative 4. And the x plus 3 factor is going to be 0 at negative 3. Now, because of the two bottom factors, it does not change in any way how I do this because there's no absolute value signs. I'm still going to talk about how positive 4 makes this actually not only just 0 but undefined. It is going to be negative for smaller values of 4, positive for larger values of 4. The x plus 4 factor is 0 at negative 4, undefined because it's in the denominator. And again, the smaller values are going to make it negative. Larger than negative 4 values are going to make it positive. All right. The x minus 4 factor here is 0 at positive 4. It's in the numerator, so it's a 0. But the same idea that it's going to be negative to the left and positive on the right. The x plus 3 factor is 0 at negative 3, and again negative to the left and positive to the right. Now, how I intend to do this one, because part of it is inside the absolute value and part of it is not. Not all of the signs are going to automatically need to be changed to positive. The denominator, because it doesn't have absolute value signs, it will stay as whatever signs it is. If it's positive, it's great. If it's negative, it stays negative, that's fine as well. It's only the top that has to change. So when I go to decide about some of these signs or how it's going to be written, I'm going to treat it actually in sections. I'm not going to just straight up multiply and divide all of these signs. I'm going to actually think about the 4 sections: lower than negative 4, in between negative 4 and negative 3, in between negative 3 and 4, and after positive 4. So what I'm actually going to do is I'm going to talk about how these factors are going to look when I take them out of the absolute value sign. So the bottom ones here, the bottom factors, are not going to change. So my x minus 4 and my x plus 4 are going to stay exactly the same. So for here and here, these are not going to change. Now, when x minus 4, that was one of the factors in the top, comes out of the absolute value sign, it is negative in this section right here, in this first section. So when I take it out of the absolute value sign, I have to make it negative. That takes care of this piece. This x plus 3 factor is also negative, and so when I take it out, it also has to have that extra negative sign. So now that it has no absolute value signs, we can talk about simplifying this expression. Now I can actually go through and do some of the canceling that I wanted to do before. For example, the x minus 4's cancel. A negative and a negative cancel. So what I have left here is simplified down to an x plus 3 and an x plus 4. This expression that I now have here is equivalent to the original question for values of x that are less than negative 4. So when we talk about going from negative infinity up to, now this is where we have a little bit of a tricky spot. Do I include negative 4? Do I not include negative 4? What I will do as kind of standard practice is when I have a 0, the zeros tend to go with the positives. That's what we noticed when we were looking at the definition of an absolute value, is if it was 0 or positive, it stayed the same. If it was negative, so those negative values, I'm just going to not include where they would be negative or 0 or undefined. Okay? All right. Now what I'm going to do is I'm going to talk about the second section. That's in between negative 4 and negative 3. So when I look at my factors, the x minus 4, the x plus 4, the signs do not matter because the denominator is not in an absolute value sign, so it is going to stay exactly the same as it is. No changes. But when I move up to the x minus 4, it was negative. The x minus or x plus 3 factor, they were both negative. And when we take something out of absolute value signs that is negative, it is actually going to need to be changed to the opposite sign. And so that's what those extra negatives are going to be. Now you're probably saying, well, this looks identical to this one. And it is. So when you cancel the x minus 4s, the negatives cancel each other out. We're left with x plus 3 and an x plus 4 in the denominator. And so what values are we including? Well, negative 4 is not even included anyway because of the undefined. We cannot substitute a negative 4 into this expression at any time. It would make the denominator a 0. So from negative 4 up to negative 3. So because we were talking about here, this 0 where negative 3 is, I'm going to include it when I do the next section to negative 3. Okay? All right. Third section, we're talking about between negative 3 and positive 4. So when I take the denominator, again, there are no changes to the denominator between here. Now, when I look straight up between negative 3 and negative 4, the x minus 4 that was part of the numerator was negative. So when I take it out of the absolute value signs, I need that extra negative. But now the x plus 3 was positive in this section, and it doesn't need to change. If it's positive, I don't need that extra negative. So I do have some things that can cancel. Then x minus 4 and an x minus 4 can cancel now that there's no absolute value signs. But what's left is a negative in front of this x plus 3, and that x plus 4 is in the denominator. And I was talking about from negative 3. Now that negative 3 value, I include the 0 with these positives. So actually I'm going to include the negative 3 here up to 4. Now 4 is undefined, so I can't include it anyway, so it's not going to be part of my solution set. All right. Fourth section, got to squish it in here. Same idea, the denominator is not in absolute value signs. We do not need to worry about changing it when we look at whether it's positive or negative. Now everything, the other factors that were in absolute value signs are positive here. So when I pull them out, I do not need to make any changes. The x minus 4 will stay as it is, no extra negative. The x plus 3 is going to stay as it is, no extra negative. And now that there's no absolute value signs, I can do some canceling and reducing, meaning that now I have an x plus 3 in the top and an x plus 4 in the bottom. And That's for values of x that were from 4. Now 4 can't be included again because it was undefined at some point, to positive infinity. 4 different sections to sort out where those absolute value factors are going to be positive and negative. Looking at this, I may choose to simplify this down to the 1, 2, 3 that are alike. I could write them as 1 and combine the interval notations that include all of those same expressions. The 1 that is different with the 1 interval where it is a different set of values that we would have that extra negative. But remember what the goal is here. If I were to evaluate any of these expressions here for a specific value, it would have to be equivalent to the original question. All I'm doing is rewriting it so that it is equivalent, but we needed to know where it's going to be a different expression, where it can be simplified. And so it depends on what value of x you want to substitute in, that you would pick one of these expressions to be the equivalent of the original. So because we had part of it not in absolute value signs, we needed to treat it in sections. And that's actually what you're going to see in the last example for today. This is now different in 2 capacities. 1, it is an adding expression. There's no multiplying and dividing. And there's not much factoring for us to do. But because we have a piece of it that is not in absolute value signs, now we're going to need to think of it in sections. Okay? So, same idea. I'm going to factor what I can. The only expression that can be factored is in the front. And I don't know if it makes that much difference, but we will follow a pattern that we have here. Okay? Now, I'm probably not giving myself enough room. I'm going to move this up so that I give myself a little bit more room. I was squished last time. Because now what I'm still going to do is sign analysis. The same as what I did before. I need to see my sections. So let's take a look at what my sign analysis is going to include. There is a factor of 3. There is a factor of x minus 3, and there is a factor of x plus 2. So again, sign analysis, I need to know where these factors are going to be zeros and positives and negatives. Now this value of 3, sometimes people will say, well, is it even necessary? It's a constant. It is always the same. It's never going to be equal to 0. For the most part, I wouldn't even worry about this value of 3 because 3 is going to always be positive. There is no time when the value 3 is going to be 0 or negative. And positives really don't change things. But had that constant been a negative number and it was negative all the time, negative numbers all the time will have a change on the overall sign of our expression. So it is sometimes important to include that constant. The x minus 3 factor is going to be 0 at positive 3, negative for values smaller than 3, positive for values that are larger than 3. The x plus 2 factor is going to be 0 at negative 2, and negative for values that are smaller than negative 2, and positive for values that are larger than negative 2. So once again, what I'm going to do is I'm not going to worry about combining the signs. I really can't this time because adding rules of integers is not the same as multiplying and dividing. I'm going to treat it in sections. There's below negative 2, there's between negative 2 and 3, and then there's greater than negative 3. So when I go to rewrite this without absolute value signs, I have 3 sections that I'm going to look at. Now I need to mimic the original question. These are added together. So when I take the 3 that is multiplied to the x minus 3 in this first section, it is negative. So I'm going to have to multiply that 3 by a negative with that x minus 3. And it looks a little bit odd, but that's what we need to do, because in this section, less than negative 2, this factor was negative, and so to rewrite it without the absolute value sign, we need that extra negative. All right, mimicking the question. The question then said to add. Rewriting the x plus 2 factor without the absolute value signs in this section, it was negative. So to rewrite it, we're going to need a negative with an x plus 2. Keeping in mind, this is for this section that we are going from negative infinity up to negative 2. Now remember, the zeros are going to go with the positives. That's when I will include 3 was when it goes with the positives, or negative 2 when it's with the positives. So we're going to go up to negative 2 and not include negative 2. Now this entire expression has some work to be done. I can simplify it. Let's just take a look at what we would have. We would have a negative 3 times an x minus 3 minus an x plus 2, which is going to be negative 3x plus 9 minus x minus 2. So this expression is going to be simplified to negative 4x plus 7 in this interval. So again, remember what we're saying here is if I wanted to evaluate this original expression for any value that's lower than negative 2, I could just plug it into this expression of negative 4x plus 7. It would be equivalent to the original. That's what we're trying to do. A simplified expression without any absolute value signs. All right, second section, between negative 2 and positive 3. So mimicking the question, the 3 is positive, no changes. The x minus 3 factor is negative in this section, so I'm going to have a negative in front of that x minus 3. Adding to mimic the question. Now the x plus 2 factor in this section is positive. I don't have to change the sign. I can just write it as it is. And again, this is for the interval from negative 2. This time I'm including the negative 2 because it is part of that 0 goes with the plus signs. Up to 3. I'm not including the 3 this time because I'll save the 3 to go with this section. But this can be simplified. I have negative 3 times that x minus 3 plus the x plus 2, negative 3x plus 9 plus x plus 2 gives us an expression that is negative 2x plus 11. And that would be the expression we could use in this interval. All right. Third section. Oops, I'm trying to maintain some colors here so that it flows a little bit. The third section. Third section, everything's positive. So I can drop the absolute value signs. Oops, that's supposed to be a minus sign. I can drop the absolute value signs and I do not need to make any changes. And so I have 3x minus, oh, there I go. I was trying to keep colors. Sorry. 3x minus 9 plus x plus 2 is going to give me 4x minus 7. And that is for that last section where we are talking about 3, including 3, and going forward. So that's what we're going to do for today. Today's practice is just about being able to rewrite absolute value expressions without the absolute value signs. Again, if there's any piece of the original question that is not in absolute value signs, we have to take it one section at a time. Like the last example, the second example, there was part of it not an absolute value sign, so we had to treat it like sections, as compared to the first example, where the expression was entirely inside of the absolute value sign, so it was easy for us just to go back to straight up multiplying and multiplying those positives and negatives. But that's everything for today. Have a good day.